So let's discuss a problem from GATE 2021 physics. This is from mathematical physics. So it is related to the contour integral and semicircular path, and here we need to find out summation of ion. So this is the problem. So a contour integral is defined as, so this is the contour integral, ion integration of closed path dz by divided by z minus n whole square plus pi square, where n is a positive integer and c is closed contour, and c as shown in the figure consisting of the line from minus 100 to plus 100. So this is the figure. So here you can see minus 100 to plus 100, and it is following the semicircular path, and the semicircle transfers in the counterclockwise direction. So this is anti-clockwise direction and this is clockwise direction, so it is moving in anti-clockwise directions. So next, the value of summation n is equals to 1 to 5 in integer is, so we need to find summation of in. So for that, what we need to do is, so first of all we need to find out in, what is in. Then after finding in, we need to find this, that is n is from 1 to 5, that is I1 plus I2 plus I3 and so on, I plus I4 plus I5. So until 5 terms it's enough. So this is the how to, let us see the solution of this problem. So here we can write this integral has in, so this term as f of z dz. So that is, in the place of f of z we are having this. Other than dz and integral, the left term is this only, 1 by z minus n whole square plus pi square. Now we need to find the singularities of this. So for that, denominator is made to be equal to 0. So this is made to be equal to 0 in order to find singularities. So here if we see, now sending this pi square to that side, we will get minus pi square, and then sending the square root to that side, square root of minus pi square is nothing but square root of minus 1 into square root of pi square. We will get pi plus or minus I pi. So this is plus or minus I pi. So next what we need to do is, we need to send this minus n, here it is minus n, on going to the side it would become plus n. So n plus or minus I pi. So now here you can see these are the singular points. So singularity exists at these 2 points, at these points where n plus or minus I pi. So these are the singular points, and it is of order 1. And next thing, another important thing is splitting of, how to split this z minus n whole square plus pi square. That one we need to keep an eye. So this could be written as this, that is a minus b into a plus b. So here a is nothing but z minus n, a is z minus n, and z minus n, and b is, so it is z minus n, and b is I pi. So if we do a square minus b square, we will get this term only, a square z minus n whole square minus b square means minus pi square, minus into minus plus. So next, only z is equals to n plus I pi contributes to integral. So only z plus n pi would contribute to integral, but not all. Why means, from the diagram you can see, from this diagram, so here z is equals to n plus or minus I pi. So because it is upward, so it is not going in the downward direction. If it were a complete circle, and if it were like this 0 to 100 and plus y and minus y like that, if it were a complete circle, then we need to take out n minus I pi also. So the points which lie below this are of the form minus I pi, n plus or minus, n minus I pi, and the points which are above, they are of the form n plus I pi. So n is nothing but real value, and this is that lies along the x-axis, and the I pi imaginary part, that lies along the y-axis. So we need to eliminate n minus I pi for this reason. And another important thing we need to see here is, here we need to find the integration. So here the contour is going from minus 100 to plus 100 only. So here what are all the values we are given from 1 to 5. So another important point we need to check out is whether 5 plus I pi is less than 100 or not. If it were less than 100, then it would lie within this radius, inside this radius. It would have lied inside this radius. So it is of here the circle, if you see, it is of radius 100. So that one if you examine, so 5 is the last value, highest possible value in the summation given. So magnitude of 5 plus I pi by using the formula square root of a square plus b square. So this would definitely would be less than 100. So 3 square roughly if we do 9. So 25 plus 9 like that if we do, so it would be 34. So square root of 34 like that we would get. So that is like square root of square root of 34 like that, greater than square root of 34. So it should be definitely less than 100. So this until 5 it would lie. So if it were 10 plus I pi like that, then 10 square root of 10 square plus pi square. 10 square is nothing but 100, then it would have been definitely greater than 100. So that point we would have neglected. So here all the points would lie from 1 to 5. And next important thing is, so now we need to find the residue 2 pi, because integral is equal to 2 pi I into sum of all the residues. So in is nothing but 2 pi I into sum of all the residues. So now we need to find out residue. Residue had this pole, and because n minus I pi is not included in the semicircle, so only had this pole. So if we see, so residue formula for residue at this point is limit of z tends to n plus I pi. So z minus this value only, z minus n plus I pi into f of z. So f of z could be written in this form, as we have discussed. This could be written in this form. So it is written in this form, so that we need to cancel out this both. So only this one would remain. Now we need to apply limit. So if we apply limit, what would happen? N plus I pi. Yeah, plus n minus n would get cancelled. I pi plus I pi, that is 2 I pi. So finally we would get 1 by 2 I pi in the denominator. So this is the residue at this pole of first order. So to 2 pi I, and this is the only residue we are getting. So 2 pi I would cancel, and so in is 1. So here if we see, this is very important. So but they have asked the summation in, but not only in. So that is the point we need to catch out. So here in is not depending on n in any manner. So if in were is equals to n, or if suppose in were is equals to n square, then it would have depended on n. But here it is simply 1. It is not depending on the term n. So by this we can conclude that I1 is equals to 1, I2, I3, I4, I5 all are 1. By this, based on this, in is equals to 1, because it is not depending on n value anyhow. So finally what we would get is summation of in from 1 to 5. So I1 plus I2 plus that is I1 plus I2 plus I3 plus I4 plus I5, all of them are 1. So 5 times, so 5 into 1, so 5. So this is the required integral. So the answer for this is 5. Integer is 1 plus 1 plus 1, 5. So this is a problem. So thank you.